All right, you guys ready? Are you ready? Denny, are you ready? Denny's ready. All right, class. Wow. So, I didn't hear you guys. Thank you. Good. All right. So, solving equations and inequalities involving derivatives. Find the point of the graph. So here's my function. So I'm looking for f prime of x. I'm looking for s prime of x. That means find the derivative. Where f has a horizontal tangent line. F is going to have a horizontal tangent line. That's important. F is going to have a horizontal tangent line. So, think about that. Horizontal tangent line. That means that my tangent line is going straight up and down, right? Say yes.
Wait.
Horizontal?
I thought that was vertical.
Good. Thank you. Okay, so I'll see if anyone catches that.
I'm so confused.
I know. So horizontal. So what is going to be the slope of a horizontal line? 0. Perfect. Slope is going to be 0. So that means that I want to find where the slope of the tangent line is going to be equal to 0. So what I need to do is I need to find the slope first, the equation of the slope, and set it equal to 0. That's what that means. Okay? So let's find, so f prime, what's the derivative of f here? So someone help me out. What are we going to end up with?
Well,
X squared
negative.
nothing else, because that 2 is a constant, and the constant goes down to 0, right? Good. All right, so this is the equation of the derivative, which gives me the slope of the tangent, right? For derivative is always slope. So I want to find where this equation here is equal to 0. So let's set it equal to 0. So 0 equals 12x squared minus 24x. A problem like that, I look at that and I'm just like, psh, F that, right? See what I did there? F that. So what do we have to do? Factor. Thank you. Factor. So we're going to factor that. So what can I factor out of that group?
12.
I can factor out a 12. Anything else?
12x, yeah.
Very good. So 12x. And after I factor out a 12x, what's going to be left here? X minus 2. So I'm going to have, after I factor that out, I have the quantity of x minus 2. Now, one of my favorite rules in math, zero product rule. Anything times 0 is 0. Anything times 0 is 0. So since I have products, I have two things being multiplied together. So I have the 12x times the quantity of x minus 2. So both those together, okay, if I multiply, if either one of those is 0, then they're both 0, right? So I'm going to do that. So let's separate this. So I'm going to say that 12x equals 0. Divide by 12, and I got x equals 0. Good. Yes? Because 0 divided by 12 is still 0. Remember, I have 0 pizzas divided by 12 people. Do they all get the same? I haven't done that one yet. I haven't done that part yet. Okay, so the next one is going to be 0 equals x minus 2. So what am I going to do to that minus 2? Add 2 to both sides, so I get x equals. So if I plug in positive 2 right here into the x minus 2, even though that I'm going to have 24 on the outside, the inside over here is going to become 0, isn't it? Again, anything times 0 is 0. So I have two places where my function is going to be equal to, the whole thing is going to be equal to 0. So my slope is going to be equal to 0 when x equals 0 and x equals 2. So there's two places where it's going to have a horizontal tangent. Right? Horizontal tangent line. Now, where is f prime of x greater than 0? So what I'm going to do with this one here is I'm going to do a number line. And then we're going to graph it afterwards. So I have 0 and I have 2. My number line. Okay? So this right here is my x-axis on a graph. Okay? And going up this way is not the y, it would be y prime, or in this case, f prime of x. So this is the graph of the derivative. This is the graph of the derivative here. Now, in my graph of the derivative, anything that is above the axis are what type of numbers? Positive. So that means that everything above here, I'm going to have a positive slope, right? Everything below the x-axis, I have a, and where it crosses the x-axis, it's going to be 0. And I know it's crossing at both of those. So we're going to do some test numbers here, just to show what we have. So let's go -1, +1, and 3. It was we have it was 12 x. Okay, still the graph of the derivative, but I'm going to leave it in its factored form because it's going to make my life a little bit easier. You'll see why. Yum yum. You're giving me that crazy look again. What's wrong?
What?
You gave me that crazy look right there.
What crazy look?
Crazy look that was right before
That's my
that.
thinking look.
Okay.
And do that so I can do this.
Okay.
I got ADHD.
Oh, you like to add also?
I got ADHD.
Ah, see what it is.
Yes.
See, math teacher.
Hey, your ADHD is helpful.
Yeah.
Makes
Get
life
it.
easier. And what?
Okay, so it's factored, so when I plug in a value, it's going to make it a little bit easier here. So if I plug in -1, that's going to be -12, isn't it? Yes? And if I plug in -1 here, I get -3. Yes? So a negative times a negative is a positive. So all these values over here is going to be a positive. The reason why I know it's everything on this side over here, is it ever going to be 0 again? Say no. No. The reason why I know it's not going to be 0, because if it goes to 0 again, I would have it in my equation when I found it, and if it went to negative, it would have to cross the x-axis. It would have to cross the x-axis here. Wow, what did that do? Ah, sorry. I know it does. Supposedly they did buy me a new smart board. Supposedly. Supposedly it is somewhere. But since, this is lovely government, it was supposed to be purchased like 2 years ago. But yeah, just like all government work, it doesn't actually have to be good. It just eventually has to be done. That's the reason why everyone's smart boards in this building doesn't work. Government work. When they installed it, they didn't install it correctly, and then no one came back to actually ever fix it. So all smart boards are broken. Except for mine, because I still fix mine myself. Anyway, alright, so get back to this. So everything over here on the left side is going to be positive. And if it was going to be different, then it would have to cross the x-axis again, and I did not find that in my equation. So now the next one I'm going to plug in is a +1. So if I plug in +1, I'm going to get a +12, and I'm going to get a -1, right? And so this one right here is a f prime of positive 1. This one right here was f prime of negative 1. And this one right here is going to be a negative 12. So it tells me that in between 0 and 2, everything down here is going to be negative, right?
Yes.
So all my slopes of my graph in between 0 and 2 are going to be negative. That's a negative, not a cyclops winking. All right, so next one, f prime of 3. So that's going to be a positive 36, and that's going to be, let me see, 3, positive 1, right? That's going to give me a positive 36, so everything right here is going to be positive. So from 2 all the way over is positive, right?
Yeah.
So the graph of the derivative, if it's positive, negative, positive, that should be a, what's this thing called? Parabola. It is going to be a parabola. Why do I know it's a parabola? X squared, the degree of the polynomial is going to tell me the shape. If it's an x squared, it is a parabola. If it's a positive, right, it's opening upwards. If it's negative, it opens downwards. There we go. And so my function right here is x cubed. What shape is the x cubed? Kind of an S shape, right? So if I were to try and show it with my hands, I would go like this, right?
No.
Yes, right. But hold on. It's positive, so it opens up this way, right? So it starts down here, ends up here. And if it is x squared parabola, it goes here, negative goes here, right? Okay, so I'm going to have you guys start doing that here soon. So you, instead of having to graph it yourself, you could actually just do the hand motions. Okay. Or instead of throwing up gang signs. See what I did that? Kind of ghetto. Yeah, see? Anyway. All right. Differentiate the function y equals e to the x. So the derivative of e to the x is e to the x. Yeah, it's it. Super easy, right? So the derivative of e to the x is e to the x. That is the slope of the function is always the slope of the derivative also. That's how we can actually figure out the slope. It's one of those things. It's just a weirdo. I don't know who eventually came up with the idea for this, but some crackhead decided, hey, that's going to work, and guess what? It works every time. Yeah, it's just super easy. Okay, so the derivative of e to the x is e to the x. So it's almost like it's on one of your flashcards too, but you ain't heard it from me because I ain't one to gossip. Nope. So, right here. F prime of x. Start with this thing right here. What's the derivative of e to the x?
E to the x.
What's the number that's in front of that?
4.
4. So this is going to become what?
4 e to the x.
Yep. Plus what?
X squared.
3
Oh, 3x squared,
x squared. Is that crazy?
yeah. Nope, it's fine.
Yeah, that's like super crazy, right? It is what it is. Make sense? Good. Make sure you all like, share, and subscribe. There is new merch in the merch store. Go ahead and buy something for the merch store. Support my channel. Huh? The new merch? It's the Diddy wear. I have a kid in one of my class. His name is Sean, and so he came to summer school high. So I've been calling him P Diddy. He is Puff Daddy, and so yeah. And then he wanted to be on a T-shirt, so I said okay. So yes, you gotta check the new merchant in store.